Welcome to another Mathnificent conversation featuring adding and subtracting fractions with like denominators. It's your nerdy math bestie Lex. Grab your pencils and let's go. Welcome to- Before we get started, I'm going to start off with a few facts about adding and subtracting fractions. To start, in all areas of math, I don't care if you're in elementary school, if you're in algebra, if you're in calculus, if you're in geometry, whatever course you're in, you can only add or subtract terms that we say are alike, and we call them like terms. We usually don't bring up like terms until we get to variables, but you can think of a lot of different things as like terms. For fractions, the denominator is what determines like terms. Fractions with the same denominator are going to be like terms, and that means they can be added or subtracted. The denominator is what tells us how many parts the whole is divided into. Therefore, if fractions have the same denominator, they're going to have equal size parts. And because the parts are equal in size, they can be added or subtracted because that's what makes them like terms. And as we go through this lesson, I want you to think about apples and oranges. You cannot add apples and oranges. You just have to keep them separate. I've got 2 apples. I've got 3 oranges. Same thing applies to fractions. The denominator is telling us what group this belongs to, and we can only add the fractions or subtract the fractions that are part of the same group. We're going to start off with fractions that have the same denominator, then we'll move to fractions that have unlike denominators. So in this problem, we're asked to add 1/4 and 2/4. In math, the more you can picture in your head and know what the picture looks like, the easier it gets. So for 1/4, that means I have something split up into 4 equal parts, and I have one of them. And I want to add that to 2/4, which means I have something that's 4 equal parts, and I have 2 of those 4ths. Okay. I'm going to combine those to see what the result is. So I know my answer should still be a whole split into 4 equal parts. I started with 1 and I added 2, which means I've ended up with 3 out of the 4 equal parts. This is why when you're adding and subtracting fractions with the same denominator, we add across the numerators, but we keep the denominator the same because we still are in equal parts of 4. Okay, our next example, 2/7 plus 4/7. So we know our like term is 7ths. That means we should have whole, some type of whole that's split into 7 equal parts. And notice the wholes that I have drawn are the same size. So you have to remember when we're dealing with fractions, everything is about size, and size is very important. The size of my 7ths for each 3 is the exact same size, and that's very important because the parts have to remain the same size. So my first, I have a whole split into 7 equal parts, and I have 2 of them, and I'm going to add that to a whole split in 7 equal parts, and I have 4 of them. So when we combine that, you can see we end up with 6 out of 7 equal parts. So 2 out of 7 plus 4 out of 7 is 6 out of 7. If you add the numerator, 2 plus 4, you get 6. Keep the denominator the same because remember the name of the game is like terms. If I started with sevenths, I end with sevenths. Okay, we've already gotten into a rhythm. We already know we add the numerator, keep the denominator the same. So 1 plus 3 is 4, keep the denominator 8. Let's visually see what this looks like. I have something that's split into 8 equal parts, and I have one of them. I have something split into 8 equal parts, and I have 3 of them, and I want to combine those equal parts. So 1/8 and 3/8, and as we can see that we end up with 4/8. Now we're going to take this a step further because we do not like when things are not simplified in math. So this is 4 out of 8. If you have not watched the prime factorization video, please watch it because prime factorization, you will see, is a common theme. If you can do a prime factorization, simplifying becomes that much easier. 4 factors to 2 times 2. 8 factors to 2 times 2 times 2. We keep in mind something divided by itself is equal to 1. So 2 over 2 here, I'll actually show you. I can split this into 2 over 2 times 2 over 2 times 1 over 2. I have 3 2's in the bottom, 2 2's at the top. This simplifies to 1. This simplifies to 1. So now we're left with 1 times 1/2, which is 1/2. So 4 over 8 is equivalent to 1 over 2. All right, our next example, 4 out of 9 plus 6 out of 9. We already know the name of the game. Add the numerator straight across. 4 plus 6 is 10. Leave the denominators the same. So now we end up with 10 over 9. And our brain should start to say, well, I know I only have 9 equal parts. So how's that going to work? So let's look at it. We started with 4. And we add 6 to it. 1, 2, 3, 4, 5. That means I have to have another whole because I didn't have enough in just one. So now I have 4 ninths and I've added 6 ninths to it, but that's created what we call now a whole. So this right here is equivalent to 1, and this is 1 out of 9. So depending on the teacher, the class, whatever you're in, 10 over 9 is equivalent. So we know we had 10 over 9, 1 whole and 1 extra 9. And you should be able to sort of intuitively see that the number 9 can divide into the number 10 one time and leave 1 out of 9 left. Okay, we've made it to our last example. 3 out of 10 plus 9 out of 10. We already know the game. Add the numerator. 3 plus 9 is 12. Leave the denominator the same. So our answer, 3/10 plus 9/10 is equal to 12/10. Something should go off in our brain that 12 is bigger than 10. So I'm not going to have enough parts. So let's look at that. Let's start with 3. And then I'm adding 9. 1, 2, 3, 4, 5, 6, 7. That's not enough. I don't have enough tenths to add 9. So I know I need another set of tenths. And I can finish adding 8, 9. This has created a whole. This is equal to 1. And then we have 2 out of 10 over here. So that tells me 12 out of 10 is equivalent to 1 and 2/10. In math, we don't like to leave anything unsimplified. I see 12 and 10 are both even, so I know they can be simplified down. Prime factorization is always your best friend. 12 is equivalent to 2 times 2 times 3. 10 is equivalent to 2 times 5. I'm also going to simplify over here. 1 is just one whole, stays one whole. 2 out of 10, 2 is already prime, and 10 is 2 times 5. Like I showed you in the last example, a number divided by itself is 1. So 2 over 2 here simplifies to 1. 2 over 2 here simplifies to 1. So on the left side, this is 6 over 5, which we now know is equivalent to 1 whole and 1/5, which should make sense. 5 divides into 6 one complete time with 1 out of 5 left over. I hope this video was helpful. We're going to work on subtraction next with like denominators, and then I will also move into unlike denominators. Remember, you are magnificent and you're brilliant. I'll see you in the next video.